Hello everyone, can you see this board?
Good afternoon, sir. Yes, sir, it
Yes,
is
very
visible.
good. So, did you solve this tutorial? Any problem? Anywhere? Problem one. Samarth Bek, are you there? Samarth Bek, can you hear me? Sira Yashwant, are you there?
Yes, sir.
Yes, Sira. How will you solve first problem? Did you get this tutorial? ये tutorial मिला है आपको?
Yes, sir.
How will you solve first problem? If liquid is not there, then how will you solve this problem? यदि लिक्विड ना हो इस प्रॉब्लम में तब आप कैसे सॉल्व करेंगे? Sira, I can't wait for such a long time.
Sir,
Yes.
I solved this sum with the standard method, with repetitively using the Lenz-Becker formula. But is there any way to find the cardinal points in that combination?
So what is being asked here? The focal length of this combination. So all I want from you, how will you find focal length of either this combination or just only the lens?
So we will keep the object at minus infinity and see where the image comes.
And where do you get the image? How will you calculate the position of image?
We will use refraction formula 2 times.
1 minute. Sira, you please answer first.
Sorry, sir, but I'm not sure about it.
If liquid is not there, then how will you solve this problem?
So by taking R as 15 V, it's given radius of curvature.
Sorry, say it again. What are you asking?
So refractive index is given as 1.6.
Mhm.
Um,
So liquid has 1.6 refractive index. Let us ignore the liquid for now. Let us ignore the liquid so that we
okay, the
just
combination is 1.5.
how will you find focal length of this lens only? So So I am asking a even easier problem. How will you find focal length of the lens? So only this problem.
Sir,
No, only Sira will answer. No one else. So only this is the lens and it has refractive index 1.5. Yes, Sira.
sir, can you show the figure once again?
Even if you take this whole hour, I can spend, but you will have to answer. How will you solve this problem?
I'm very sorry, sir.
How will you find focal length of this lens? This has radius of curvature, let us say 10 centimeter. This side has radius of curvature, let us say 20 centimeter. So this is a convex lens and it is made of glass. How will you find focal length of this lens?
So it will be 10 centimeters, right?
लेंस में का
For the-
फॉर्मूला
How do you know that? How do you calculate it?
So it's r/2 for the focal length.
R by 2. Which R you are taking here?
So for the right one, it will be 10 centimeters,
And for the left one?
5 centimeters, sir.
So do you mean there are two focal lengths for this lens?
Um,
How many focal lengths does single lens have?
sir, on the either side, they should be right.
So I have this question for you. I place this lens here. This side has curvature 10 centimeter. This side has curvature 20 centimeter. Some rays are coming from infinity. Where will they converge? ये कहाँ converge करेंगे? At a distance of 10 centimeter or 5 centimeter?
10 centimeters, sir.
10 centimeter.
Or the combination.
You mean here, huh?
Yes, sir, but I'm not sure.
And if I flip the lens means now this side is 20 centimeter and this side is 10 centimeter and rays are again coming from infinity. Where will they converge?
Sir, I guess there should be a combination formula, but
Use whatever formula you have. Just give me the answer. Or even let me ask you even simpler question. Will they again focus at the same point or they will focus at some other point?
they should be at the other, sir.
Other side means here. So do you mean that the
No,
rays?
not there, sir. So it should be right only,
Hmm.
but I don't know like which point?
Sira, are you interested in doing BTech?
Yes, sir.
Which branch are you in?
Sir, I'm in CSC.
Computer science, huh?
Yes, sir.
This is something which you should know in your 10 plus 2 also, right? Image making by a single lens is there in your intermediate syllabus as well. Then why is it that you do not know all these things? सिंगल लेंस तो आपने +2 में पढ़ा है ना?
Sorry, sir.
Actually, we should feel sorry for you. It looks like we are wasting your time. Do what you think good for you. We have no intention to force you to come into class and listen to us. Do you want to suggest anything to me regarding teaching, regarding explanation? क्या हमारी तरफ से भी कोई फॉल्ट है ऐसा जो हम कवर नहीं कर पा रहे हैं?
No, sir. It's completely my fault.
कॉम्बिनेशन नहीं समझ में आता है, आई एग्री, बट जो आप +2 में पढ़ के आए वो भी आपको क्लियर नहीं है और आप पूछने की जरूरत भी नहीं समझते. There are countries where getting education is like students have to do part-time job along with their classes. कंट्रीज ऐसे भी हैं जहाँ फीस इतनी ज्यादा है कि पढ़ने के लिए लोग पार्ट टाइम जॉब भी करते हैं. आपको कुछ बिना एफर्ट के मिल जाता है और आपको कोई इज्जत नहीं है उसकी. हाँ, Sintu Kumar, are you there?
Yes, sir.
How many focal length does a single lens have?
2.
2. Please tell me what is the focal length of this convex lens? This one. Either say I know, I am going to solve, or you say I don't know, but please don't waste time like this. आपको पता है कैसे सॉल्व करना है?
Yes, sir.
बताइए कैसे सॉल्व करेंगे?
1 upon f equals to 1 mu minus 1 mu2 upon mu1 minus 1 into 1 upon r1 minus 1 upon r2.
1 upon f is equal to mu2, then
equals to mu2 upon mu1
okay,
minus 1
all right.
into 1 upon r1 minus 1 upon r2.
What is mu2 here?
mu2 is lens refractive index.
So
And
1
mu1
or something else.
1.5, sir. mu2 is 1.5.
What is mu1?
1.
What is r1?
10 centimeter.
What is r2?
Minus 20 centimeter.
So this is the answer, right? You will get some result here.
Yes, sir.
Let us say this result is okay, let us solve it. They will get some number. This is half. Sorry, 1.5 minus 1 is half. 1 by 10 plus 1 by 20. 3 upon 20. This is how much? 40 by 3. Okay. So I should get image at 40 by 3 distance. And if I flip the lens, then if I flip this lens so that now radius of curvatures are on opposite sides, will the rays converge at the same point or at some other point? क्या अभी भी उसी point पे ray converge करेंगी या किसी और point पर? Will the focal length remain same? क्या focal length अभी भी same होगा? सिंधु कुमार, are you there?
Yes, sir.
Focal length same रहेगा या बदल जाएगा? आपने लेंस को 180 डिग्री घुमा करके वहीं रख दिया दोबारा से.
सेम रहेगा सर.
Same रहेगा. Okay. What about this lens? So one side has curvature how much? 15 and one side has 30. Which side has curvature 15? Side A or side B? This is the figure. Top side has 15 radius of curvature or bottom side has 15 radius of curvature?
Bottom side, sir.
Bottom side has 15 radius of curvature. So 15 is this. 30 is this. Okay. What is the focal length of this combination? Light is coming from this side.
Yes, sir. From previous formula, we can find the focal length of.
So
Also,
is it a negative number or positive number? R1 means this 30. 30 रखना है minus 30 यूज करें.
it is sir, both are positive numbers, sir.
Both are positive number. Huh? Light is coming from this side. Light इस side से आ रही है.
Yes, sir.
Why positive? कैसे पता चला positive है?
Sir, we consider in the direction of light through sign convention.
So this case is equivalent to this case. ये आपका लेंस रखा है, this side is 30, this side is 15, and light is coming in this direction.
Yes, sir.
So what is R1? Plus 30 or minus 30?
Plus 30.
R2?
Plus 15.
Plus 15. ये अभी आपने कैसे डिसाइड किया था कि यहाँ पे बाइकॉन्वेक्स लेंस में कौन सा प्लस है कौन सा माइनस?
Sir, R1 are 10 centimeter, which is minus 10 centimeter. I think there should be, sir.
तो यहाँ मिस्टेक हुई है आपसे, हाँ?
Yes, sir. Minus 10 centimeter, and R2 which is 20 centimeter, which should be plus 20 centimeter.
So this should be minus, this should be plus, huh?
Yes, sir.
So you are saying that I should get a negative number. आपने एक माइनस से मल्टीप्लाई कर दिया है. It means I should get minus 40/3.
Minus 40/3.
ये कॉन्वेक्स लेंस है या कॉनकेव लेंस है?
Convex, sir.
कॉन्वेक्स. फोकल लेंथ कॉन्वेक्स लेंस का कैसा होता है? पॉजिटिव या नेगेटिव? पॉजिटिव मींस रे राइट में कन्वर्ज करेंगी या लेफ्ट की ओर कन्वर्ज करेंगी?
सर राइट की ओर कन्वर्ज करेगी.
तो फोकल लेंथ पॉजिटिव हुआ ना?
यस सर. कन्वेक्स में पॉजिटिव एंड कनकेव में नेगेटिव.
आप तो कह रहे हैं फोकल लेंथ नेगेटिव आ रहा है.
नो सर, नो सर, बाय मिस्टेक आई टेल यू.
बताइए कहाँ मिस्टेक कर रहे हैं?
Sir, by mistake I speak focal length will be negative, but in convex length focal length will be positive, sir, because in positive direction it converge.
तो R1 क्या है? +10 है या -10 है? फाइनल बताइए मुझे. वो कैसे
R1
आपने किया?
R1 should be -10, sir.
क्यों? आपने -10 कहा, क्यों कहा? कैसे पता चला -10 होगा?
सर थ्रू साइन कन्वेंशन.
ठीक है, कैसे पता कर रहे हैं कि क्या साइन लगेगा इसके लिए?
Sir, in the direction of light we consider positive.
सो लेंस का साइन लेंस की जगह लाइट से पता चलेगा, हाँ?
Yes sir.
लेंस का कोई मतलब नहीं है कि लेंस कहाँ है कैसा है. बात कर रहे हैं लेंस की और साइन बता रहे हैं आप लाइट के थ्रू. ऐसा होता है क्या? If I change the direction of light, then according to you, my formula will change, huh? Sajal Yadav, are you there?
Yes, sir.
So Sajal, how do you decide sign for lens surface? Like here, whether R1 is +10 or -10?
Sir, R1 will be -10.
-10. Why?
Sir, as we take object on the left hand side of the R1, 10 centimeter radius of curvature, then the sphere from which the lens is cut, we take the direction in that of light, then it would be negative.
So this is the object, this is the lens, and this is cut from this sphere, right? It is cut from this sphere. So this sphere is of radius 10 centimeter. Now, how do you decide whether this R1 should be positive or negative? कैसे आप पता करेंगे कि इसको पॉजिटिव माना जाना है या नेगेटिव?
Sir, the rays are coming from the left hand side.
ठीक है.
So the sphere is on the right hand side. So we take the sign convention of negative -1.
So R1 is negative, huh? Right. What about R2? R2 means this side. तो क्या रखेंगे आप? Positive or negative?
No, R1 will be positive, na sir, by sign convention. No sir, R1 will be positive. Sorry. R1 will be positive. R2 will be negative.
Nilanshu Roy.
Yes, sir.
R1 is positive or negative?
In this case, R1 is positive because from the periphery we are going to the center along the direction of light ray.
And why is R2 negative?
Because as we measure from the periphery of the sphere to the center, we are going against the direction of the light ray from the object.
See, the convention is quite clear. Where do you have this center? If on the right side, positive. If on the left side, negative. So this surface is obtained from this sphere. And center of this sphere is, sorry, not here, here. Center of this sphere is on the right side of the lens. Therefore, this number is positive. What about this surface? This surface is obtained from this lens, this sphere. Where is the center of this sphere? On the left of lens. Therefore, it is negative. If you flip the lens, यदि आप लेंस को फ्लिप कर देंगे तब क्या होगा? Then R1 will become negative, R2 will become positive. बट दोनों ही केस में यू कैन ट्राई, आप कोशिश कर सकते हैं. फोकल लेंथ इज पॉजिटिव, फोकल लेंथ पॉजिटिव ही आएगा. What about this lens? इस लेंस के साथ क्या हो रहा है? This is R1, this is R2. R1 क्या है? नेगेटिव या पॉजिटिव?
Sir, that depends on where we are keeping the object first.
Right. So it is a normal convention that light always go from left to right. हमेशा ही ये चीज सही मानी जाती है. And since they are transparent object, light can bend only, but it will never ever return. Light bend हो सकती है, but ये कभी भी पीछे को नहीं लौटेगी. So this is implicit convention. कभी नहीं भी बताया जाता है तब भी this remains fixed. Light is always from left to right. Now what is R1? यहाँ पे R1 क्या होगा?
R1, R2 both are negative.
Okay, and accordingly you can find the answer. So if this is the situation in problem number 1, what I expect from you for last problem? किया है किसी ने?
The last fourth?
Yes.
Yes, sir. The first part done.
First part किया है.
Sir, yes.
Where should we place the object so that final image appears at infinity? So
Sir,
let me ठीक है, अभी डिस्कस करेंगे इसे. नेक्स्ट वीक ये सबमिट करना है आपने. कब सबमिट करना है? 24 फरवरी. all of you.
सर
Yes.
इसको असाइनमेंट सेक्शन में भी डाल दीजिए.
Okay. I'll make one assignment.
Yes, sir. Both tutorial 1 and 2.
And this tutorial only, tutorial 7.
सर बोथ का कर दीजिए अगर हो सके तो.
I'll have to check the copies, so please. You write one copy, I have to check how many copies? Roughly 120, right? So where should we place the object so that final image appears at infinity? There are two lenses. Everything is same as we have discussed in class. सब कुछ वैसा ही जैसा क्लास में डिस्कस किया. Only new thing, we know the focal length in numbers. Okay. So ऑब्जेक्ट कहाँ रखा जाए कि इमेज इंफिनिटी पर बने? So field length is here. I'm just going to draw one line to keep the image clean. This is eye lens.
Sir, here we are not considering the existence of objective lens.
No. So in this problem, I am not discussing anything about objective lens. Where is the first focal point of this setup? First of all, what is the focal length of this setup?
3/4.
First lens has focal length f. Second lens has focal length f. Distance is 2f/3 into f into f. So 1 by f, what we have common? 2 minus 2/3. 6 minus 2, 4/3, 3/4f.
So 3/4.
Right? This is the focal length. But if we want to know where is the focal point, we need to know the principal point first. Minus d is 2f/3. Overall focal length is 3f/4. First lens. Actually, both lenses have same focal length, so we will get the same answer. 3 cancels, you will get minus f/2. This is beta. Alpha?
Plus f/2.
Same आ जाएगा because everything is same here. Mark all the points. So f/2. f/2 will be not in between, but so first mark h2. h2 is let us see here. How many units? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's make it 12. Okay. So this is h2. This distance is f/2. Where is h1? Same distance but from field lens. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is also f/2. Now, where is the focal point? It is 3f/4. 3f/4, right? So f2 is on the right of h2 at a distance of 3f/4. So f/2 is this distance and f/4 extra. 1, 2, 3, 4, 5, 6. So here we have f2, and similarly 1, 2, 3, 4, 5, 6. Here we have f1. This distance is f/4. This distance is f/4. So where should we place the object so that we
Sir,
finally get parallel light rays?
Sir, f1 पे.
The object should be placed here.
Yes, sir.
So after passing through these two lenses, we get parallel light ray. But after passing through just one lens, Obviously we will get image somewhere. Field length कहीं तो image बनाएगा. Where will this field length make image? ये field length से image कहाँ बनेगी?
minus f by 3.
Minus f by 3. कैसे कैलकुलेट करेंगे?
Sir, 1 by
minus f by 4. F is f ही है. B you can calculate, right? कितना मिला आपको? Minus
f by 3.
minus f by 3. So image is even on the left of object. Object से भी पीछे बन रही है. Maybe here. So this is object. Let me call it first image क्योंकि field length से बनी है. And this is the image. क्या size होगा? अभी नहीं जानते. This is image. This distance is f by 4. This distance is f by 3. If object height is h in this problem, object की height आपको मालूम है. What is the size of image made by the field length? Image का size क्या होगा? What is h prime?
Sir, हम लगा लें मैग्निफिकेशन फार्मूला सर, माइनस v by इक्वल टू h2 by h1 और वहां से
So you can use the formula or you can use the ray diagram. This ray will pass through the focal point. Focal point f distance पर है. Focal point बहुत दूर है यहाँ से. Maybe somewhere कहीं होगा इधर. Rays are going in this direction. This ray will pass as it is. ये ray तो ऐसे ही pass हो जाएगी because it is passing through center. And obviously they are not going to meet anywhere on the right. Right में कहीं meet नहीं करेंगे. They will pass through eye lens and finally they will become parallel. Eye lens से पार होने के बाद ये parallel हो जाएंगे. But if we draw them backward, इनको पीछे ले जाएंगे तो they look like coming from here. Same with this also. Okay. So there is some minor error here. How do we find image? This distance is known. आपको सारी distance मालूम है. This is u. This is b. Use a trigonometry. This angle theta. So tan theta is how much? Either you can call it h prime upon mod b, or you can call it h upon mod u. So what is h prime? H mod u upon mod v.
Sir, 4 by 3h.
Right. So u is f by 4, b is f by 3. गलत किया है क्या कुछ? Is there some mistake?
Yes, sir.
v by u होगा.
V by u.
Right, right. Because image should be larger than the object. B upon u. H. So it is how much? 4 by 3.
4 by 3.
4h upon 3. This is the object for eye lens. ये eye lens के लिए object है. And where do you get the image of this object? This
Infinity.
image. You can see this image is placed at a distance f from eye lens. Eye lens से ये object कितनी दूर पर रखा है? f by 3 plus 2f by 3 means f distance पर. That's why you get image at infinity. इसलिए आपको इसकी image infinity पे बनती मिलेगी. What is the angular magnification produced by the eyepiece? If I place eye just next to this eye lens, इस eye lens के ठीक पीछे से हम देखने की कोशिश करें, आपको क्या साइज दिखाई देगा इस ऑब्जेक्ट का?
So 4h by 3.
Let me ask you even simpler question. If I place my eye here, this dark image, dark circle, dark ellipse, will I see the same size of object and image, or will I see different size?
Same size.
But वास्तव में तो साइज अलग है ना. जो हम देखते हैं वो क्या है? Is that the reality? Even the smaller objects can look bigger. छोटे ऑब्जेक्ट्स बड़े भी दिख सकते हैं if they are very close to eye, यदि वो आंख के ज्यादा पास हो. Right? So the size that we see is different from the actual size. जो साइज हमको दिखाई देता है वो actual साइज से छोटा या बड़ा हो सकता है. How do you define कि क्या साइज मिलेगा? That will depend on this angle. इस एंगल से डिसाइड होता है. The angle made by that object or the image on the eye. जो वो ऑब्जेक्ट या इमेज आंख पे क्या एंगल बना रही है वो बताता है कि साइज कितना होगा. So same is here. What size will you see? आपको क्या साइज दिखाई देगा when you put eye here just next to eye lens? The angle made by this image on eye. इस ऑब्जेक्ट इस इमेज ने आंख पे क्या एंगल बनाया? How much is that angle? वो एंगल कितना होगा? On eye, let us say that angle is phi. So what is tan phi? What is phi here? Phi is this.
H by 3 upon.
This is the angle made by this image on eye. Phi. So obviously height of this image divided by the distance from the eye.
Yep.
So 4h by 3. इसको स्मॉल एंगल मान सकते हैं if all the rays are very close to principal axis. Height है 4h by 3 and distance कितना है?
F by 3.
F only. Eye lens से F distance पर है, right? So 4h upon 3 है. This is the size we see when we use this eyepiece. कितना साइज देखने को मिल रहा है इस eyepiece से. If we do not use this eyepiece, यदि इस eyepiece को ना यूज किया जाए, what is the maximum size you can see for this object? बिना eyepiece यूज किए ये आपका ऑब्जेक्ट है हाइट एज का, ये आंख रखी है. Obviously the size you will see depends on ये distance कितना है.
Sir, I think the distance is 5f by 4.
Look, first let me complete this part. Depending on this distance, the size may increase or decrease, right? So here I am talking about maximum size you can see without eyepiece. यदि eyepiece ना यूज करें, obviously then you are free to move this object. तब आप इस ऑब्जेक्ट को मूव भी करा सकते हैं, तो जरूरी नहीं है कि यहीं पे ही रहेगा.
H by capital D.
So the minimum distance you can have is D minimum is capital D, and in that case you can obtain the maximum magnification without using any other extra instrument. कितना आपको साइज दिखेगा? Let me call it 5 prime. H is the height, T is the distance. So this is the maximum you can get without instrument. This is what you get with instrument. Obviously when you use the instrument, अब object को आप कहीं भी move नहीं करा सकते. Depending on what kind of rays you expect, you have to put object at some particular position. आप object को move कराएंगे, आपका उसी हिसाब से यहाँ पे rays change हो जाएंगी. So it's a tradition, it is conventional also that we always try to see the object through the relaxed eye. एक attempt रहता है कि हमेशा आपको parallel rays मिले, so that थोड़ा सा आपको image देखने में आसानी हो, भले magnification थोड़ा कम आए. So this is the size you see with eyepiece. This is the size you can see without eyepiece. कितना आपने magnify कर लिया? This is called angular magnification. With instrument आपको size क्या मिला? And without instrument आपको size क्या मिला? कितना आपने मैग्नीफाई किया? D will go up, right? This. How much is this number? ये नंबर कितना है इस पर्टिकुलर केस में? D is
3/3.
right 4/23 into how much is F here? F कितना है हमारा? 4 सेंटीमीटर.
6.33.
So it is roughly
नहीं
8.
3.
So this eyepiece has the capability of magnifying the object by a factor of 8. Objects को 8 गुना बढ़ा सकती है with a quite good control on aberrations. Aberrations पे अच्छा कंट्रोल रखते हुए भी. And what is the size of this instrument? क्या साइज है इस इंस्ट्रूमेंट का? 2f/3. थोड़ा सा और बढ़ा लीजिए कवर वगैरह लगाने के लिए. F is how much? 4, right? 4 का. तो कितना साइज हुआ इस इंस्ट्रूमेंट का?
approximately 3 centimeter apart.
Roughly 3 centimeter. So it's a quite small equipment, बहुत छोटा सा equipment, and it can do a magnification of roughly 8. Usually eyepiece can magnify up to 10 times or 12 times. Eyepiece 10 से 12 गुना तक magnify कर देती है without any distortion in image. जो distortion होता है image में वो insignificant है, आप देख भी नहीं पाएंगे उसको सही से. So this is the beauty of eyepiece. This is the importance of the eyepiece. Such a small piece behave like one single lens and it can magnify much more than the single lens. Single lens से कहीं गुना अच्छा, कहीं गुना better क्वालिटी है इसका in a very small space, बहुत कम स्पेस में ही. Yes, any doubt here? कोई डाउट है किसी तरह का?
No, sir.
So this problem was designed just to tell you that eyepiece can do the wonders. अब ऐसा नहीं कि हर काम के लिए आपको टेलीस्कोप या माइक्रोस्कोप ही चाहिए. इतना मैग्निफिकेशन आप एक छोटे से इंस्ट्रूमेंट से भी कर सकते हैं. Where do we use eyepiece? कहाँ यूज करते हैं? Where we want to magnify the object by this much amount. और ये मैग्निफिकेशन काफी है. 8 times magnification is quite strong. You can use it along with existing magnifying machine. माइक्रोस्कोप, टेलीस्कोप में इनको भी इम्प्लीमेंट कर सकते हैं टू मैग्नीफाई द इमेज फर्दर. इमेज को और ज्यादा मैग्नीफाई करने के लिए. बहुत ज्यादा स्पेस नहीं लेती हैं. दे कैन बी फिट एनीवेयर, कहीं भी फिट की जा सकती है. राइट. व्हाट अबाउट रिमेनिंग प्रॉब्लम्स 2 and 3? दिस इज फॉर सिंगल लेंस. ये आपने कुछ पढ़ा भी होगा पहले, और दिस इज आल्सो मेंशन्ड इन द टेक्स्ट बुक व्हिच आई हैव प्रोवाइडेड यू. उसमें भी देख सकते हैं. दीज आर द इजियर वर्जन ऑफ प्रॉब्लम 4. प्रॉब्लम 4 का इजियर वर्जन ही है. इन प्रॉब्लम 4 वी हैव डबल लेंसेस, इसमें सिंगल लेंस ही है. सो प्लीज डू इट ऑन योर ओन. Submit these 4 problems in the assignment section and I'll check these copies.
Okay, sir.
Thank you, sir.
Okay.
Thank you, sir.
Yes, any
Thank
doubt?
you, sir.
सर
Yes.
Thank you, sir.
All right, all right. Karishma, yes.
क्वेश्चन नंबर 9 थोड़ा बता दीजिए.
Question number 9 of previous.
यस सर.
This one. Find cardinal points of glass sphere of radius r. क्या डाउट है इसमें आपको? So this is like a thick lens. ये एक तरह का thick lens हो गया. And for thick lens, what numbers do you need? R1, R2, thickness and the refractive index mu or n, जो भी आप कहते हो. It's a glass 1.5 and this is a complete sphere, right? So what is R1? R1 is the left side, which is part of this whole sphere. So R sign, center is on right, center right side में है, so positive. If lights are coming from this, यदि light इधर से आ रही है तो What about R2? R2 is right side, वो भी same sphere ही है, so it is also R. But where is center? On the left side of the surface, so minus R. Thickness?
2R.
This. How much is the thickness? 2R. Okay. So once you have these parameters, apply the formula of thick length. You will get some numbers. क्या number मिलेंगे आपको? Focal length. First focal length is obviously negative of second. H2, H1, or N1, N2 same as H1, H2. पूछा क्या गया इस प्रॉब्लम में? An object is placed at first focal point. Sorry, problem number 9. If an object touches the sphere, what is the corresponding image? But did you calculate H2? क्या आपने H2 calculate किया था? And H1?
Sir, H1 and H2 at the center of the sphere.
No. I think they will not. Is it at center? क्या center पर आएगा?
Yes, sir. Mine also came at center.
Yes, sir.
All right. Let us
H1,
say
H2.
they are come at center.
Sir,
Anyway, no problem. Let us say they come at
Yes,
center.
sir.
मान लेते सेंटर पे आता, कोई दिक्कत नहीं है. If object is just touching the surface, object यहीं पर ही रखा है. What is U? U कितना होगा बताइए? U is object to H1 distance.
Minus R.
माइनस R. H1 के लेफ्ट में है, कितनी दूरी पर? माइनस R दूरी पर. फोकल लेंथ आपने कैलकुलेट किया है. Use this formula to find B. Okay. You will get some number. इमेज कहाँ बनेगी? H2 से B डिस्टेंस पर. पॉजिटिव आता है सो मूव टुवर्ड्स राइट बाय B डिस्टेंस. नेगेटिव आता है तो लेफ्ट की ओर. Okay. So can you do it now?
Yes, sir.
Do it and compare with your friends. If you get different results, then let me know. In fact, this is the solved problem in textbook. ये problem शायद solve की हुई है textbook में. So you can take help of book also. All right.
Okay.
So I'm going to end this class now.
thank you.
Thank you, sir.
Thank you, sir.
Thank you.